Hey, how's it going, Wildcats? Welcome. This is Mr. Walk, and we're going to be doing our very first set of notes for Algebra 2. Now, what we're going to be looking at today is what is called linear functions. This is actually a review of Algebra 1, so everything we're going to see here in theory, you should have already learned it and already practiced this. But we're going to review it because it's important information and it's foundational information for what we're going to be doing in Algebra 2. Just to give you a quick overview, linear functions, which is what we're going to be reviewing here, is going to be graphs that go in a straight line. Maybe a graph like that could be going up, could be going down. There's different types. This is just one type of function, and in Algebra 2 we're going to be learning about all different other types of functions which are not going to be straight lines. For example, we're going to see graphs that curve like this, or graphs that curve like this, or like this, or like this. All different types of graphs that curve. And of course, we're not only going to work with the graphs, we're going to work with their corresponding equations. So before we get into this stuff, before we get into all this stuff here, which is coming a little bit later in the semester and in the school year, we're going to review just the graphs and equations of straight lines, linear functions. So let's start off with this here. The steepness of a line is called the slope. Hopefully you remember this word, slope. And it says here, the letter that we use for the slope is a lowercase m. Lowercase m. Now, you know what? I never knew why the letter m was used to represent slope, because obviously there's no m in the word slope. But this is kind of interesting. I just learned this recently. Okay, it comes from this French word here, and I don't know how to pronounce French, so I won't try. But that's where we get it from. Okay, so moving on here. When given the graph of a line, we need to know a simple definition of slope. Okay, so what does it mean? M, our slope, is equal to, we're going to make a fraction line here. In the top of the fraction is going to be rise, and in the bottom of the fraction is going to be run. Rise over run. Hopefully you've heard that before. Okay, the rise is how much is the graph going up or down, and the run is how much is the graph going from the left to the right. All right, let's see here. Slope is the ratio of a line's vertical change to its horizontal change. That's what we mean by rise over run. So this is really just another way of saying the same thing. Okay, vertical is up and down, the rise, horizontal is left to right, the run, and we're looking at that ratio, the relationship between the vertical and horizontal change. Okay, let's take a look at this part here. How to find slope when given the graph of a line. Okay, so step one, mark some points on the line. Okay, let's do that. Let's mark some points on the line. Now, when you have a graph, ideally you want to mark points that are on the grid. So meaning this would be a good point, because look, that's right on the grid. Okay, this point here, not so good, because I know it's on this line here, but like here, it's not on a line, it's in between two. So I wouldn't want to pick that point. So we'll start with this point, and we need 2 points. So that's one. I need to find one other that's on the grid. Let me go right there. That one's on the grid. So I've got our 2 points. I'll zoom in here just so we can see that. Okay, start from the left point. You know what? When we read graphs, we do it just like we're reading a sentence on a piece of paper, just like we're reading a book, from the left to the right. We always want to go from left to right. So start from the point that's on the left, so that would be this guy. Find the rise. So how much are we going up or down to the next point? Well, to go from here to here, I'm going up, right? The graph is going up. So let me do this. Let me hold up. Let me make this smaller. Okay. So this is how much we're going up, just to the next line. So that's 1. We're going up 1 unit here. Okay, so the rise is a 1. Okay, and let's see. You know what? I guess to fill this in, let's fill this part in. Find the rise. Up is positive. This is what we want to put in here. If we're going up, it's going to be a positive number. If we're going down, it's going to be a negative number. So here, this is a positive 1. Find the run. Okay, and the run, see here it says try to always run right. Well, yeah, always go to the right. We're starting from the left and we're going to the right. So from here, how far am I going to get to that next point? Well, that's 2. Okay, so my rise is a 1, my run is a 2. The definition of slope is rise over run. So over here, rise goes on top, that's a 1. Run goes on the bottom, that's a 2. There's my slope. Okay, this is the rise, this is the run. All right, slope of 1/2 for this line. Okay, so take a look here. These are some for you to try. There's 3 graphs here. I want you to pause the video and see if you can figure out what the slope is using this same method. Start by finding a point, or excuse me, finding 2 points. You got to start by finding 2 points that are on the grid. Start from the left point, going to the right point, figure out how much you have to go up or down. If it's up, it's a positive number. If it's down, it's negative. Then how much you have to go to the right. And then you'll put that in a fraction form. Go ahead, give those a try, pause the video, then we'll come back and do it together. All right, let's go ahead and take a look at these examples. All right, that's what we got for those 3 examples. Check your work. If you didn't get the same thing, maybe double check what I did. If you're still not sure, ask me a question, okay? When you see me in class, you'll probably be watching this video during class time, but sometimes you'll be watching these videos at home. You can just write down a note to yourself to ask me, or ask your teacher to go over this, okay? If you're not getting the same answer. But there's 3 examples there. Let's keep going with the notes here. Okay, here at the bottom of page 1, there are 4 types of slopes. All right, so let's look at the first one here on the top left. Okay, as we travel left to right, remember, we're always reading the graphs going left to right. Okay, because if you look at this line, you say, well, is it going up or is it going down? It depends, right? If you're here and going this way, you're going up. But if you start here and you go this way, you're going down. Okay, so don't confuse yourself. We're always starting from the left and going to the right, just like you read a sentence. As we go from left to right, this graph clearly goes up. And any line that goes up has a positive slope. So we're going to put here positive. All right. And then now this graph going from the left to the right, it's clearly going down. A graph that goes down has negative slope. That means if we calculate the slope, it's going to be some number that's going to be a negative number. Okay, let's go down here. Now take a look at this line. Is this graph here, is it going up or going down? Neither, right? It's not doing either. It's just a flat line, staying flat. This is a horizontal line. Okay, a horizontal line that just goes straight from left to right has a slope of 0. Okay, so a graph that goes up has a positive number. A graph that goes down has a negative number. Okay, a graph that does neither, doesn't go up, doesn't go down, has a slope that's neither positive or negative. The only number that's not a positive and also not a negative is the number 0. And this, by the way, is a horizontal line. Okay. And then our last case here is a vertical line. This is a line that's going straight up and down. Okay, vertical line. And technically this type of a line doesn't have a slope because it doesn't have any run. It only has rise. It has what you might think of as infinite rise. It's going straight up and it doesn't have any run. It's not going left to right. What we call this is undefined slope. Okay, there we have our 4 cases for types of slope. All right, hey, let's go ahead and take a look at the back side of these notes. And at the top here, it starts us off with one of those silly sayings that might help you remember something. So you probably come across these before. This is what it is. Hoi vux. Okay, if this helps you, you can use it. If not, don't worry about it. Hoi vux is a little saying that could help you remember two of our types of slopes for our horizontal and vertical lines. So this goes back to what we just finished on the front side of the page. Let's go ahead here. So the H here stands for horizontal, and then the V over here stands for vertical. Okay, the O here is actually not the letter O, it's the number 0, because every horizontal line has a slope of 0. So I'll just write here slope. You could also put M if you want. Remember, if we wrote it like this, this is another way of writing the same thing. M, which stands for slope, equals 0. Okay, now the Y down here at the bottom is because any horizontal line is going to have an equation that looks like this. Y equals, now that there is not a hashtag. Matter of fact, we used to call that a pound sign, but that just means any number. Okay, so Y equals some number. That's the equation of a horizontal line. And here's an example. Could be Y equals 4, or it could be Y equals -2. Y equals any number is always going to be a horizontal line, and it's going to have a slope of 0. Oh, and let me not forget, just a reminder, what does a horizontal line look like? Straight, flat line, left to right, not going up, not going down. That's our horizontal. Okay, so that's what HOY means, right? The HOY is just to help you remember all this information here. Now we get to the VOOCs. V stands for vertical. U stands for undefined. Undefined slope. Because a vertical line has no slope. Its slope is undefined. Remember, a vertical line looks like this, going straight up and straight down. So it's got all rise and no run. And the equation of a vertical line will always be in this form. X equals some number. Let's see, X equals 5. That's just a random example. Here's another one. X equals -12. Those are just examples. X equals a number. That's going to give you a vertical line with undefined slope. So that's what this top little piece is right here. HOY VOOCs. Okay, let's take a look at these next examples. What we're doing here is simplifying fraction. And this is an important skill to know. And it's something that we put to use when working with slope, because our slope always comes in the form of a fraction. Remember, the definition of a slope is rise over run. That means it's a fraction with rise in the numerator and run in the denominator. And anytime we have a fraction, we want to simplify it. So something like this here, 2/4, you learned at some point, probably in elementary school, how to simplify this by hand. That's not what we're going to be doing here. Of course, if you want a reminder on that, you can ask me during class. I'll show you. What we're going to be using here is technology to do this. Now, you can do this on the handheld calculators that we're going to check out from the library. The way I'm going to show you how to do it right now is using Desmos. This is the best calculator that we have available to us. It's also a very important calculator to know how to use, because it's going to be on the state test at the end of the year for the juniors. All right, so just go to any browser, type it in, DESMOS. Let me try that again, DESMOS.com, hit enter, click the button that says Graphing Calculator. And here we've got a graph on the right, and we have on the left side where we can input some numbers and equations. Right now, we're not really worried with the graph. We're just using the calculator part on the left. So I'm going to type in 2/4, 2/4. I get the fraction. Right away, Desmos tells me down here its equivalent decimal value, which is 0.5. So 2/4 is equal to 0.5. However, that's not what we want here. We want a fraction answer in simplified form. Well, that can be done as simply as clicking this button right here. So when I click the button, now it changes the answer from a decimal to a fraction, and it's in simplified form. So we see here that 2/4 simplifies to 1/2. That's our answer. 1/2. Okay, so what I want you to do now is you try the rest of these before we go over them together. Before I show them to you, I want you to try them. So pause the video, go to Desmos, and simplify the fraction. Then you can come back and watch the rest. All right, hey, these are the answers I got here for simplifying the fractions. So 35/40 is equal to 7/8. 10/16 is equal to 5/8. And 8/36 is equal to 2/9. And hopefully you got those same answers. If not, ask me and I can go over it with you. I can take a look at what you're doing, okay? All right, let's keep going here. So basically what we have here on this last piece is a way to figure out the slope when we don't have a graph, but we know the coordinates of 2 points, okay? So, right, this is what it says here. The slope of a line containing 2 points. And look, these are just 2 generic points right here. We're going to be working with specific examples where these will be numbers. We'll see what that looks like. The formula to calculate the slope, here it is. M is our slope. It's equal to, remember, it's equal to a fraction with the rise on the top and the run on the bottom. And the way that we calculate the rise from the points is this: y2 minus y1. And the run, which is going to be in the denominator, x2 minus x1. Okay, that's the formula for this piece here. In other words, M is the change in, well, look, these are y values on the top, and these are x values on the bottom. So that's what we're going to put over here. M is the change in y, which represents our rise, over change in x, which represents our run. Okay, look, let's do an example. We got 3 of them here. I'm going to do the first one right now to show you how to do it, and then I'll let you try the other 2. Okay, so look, we have 2 points. Now, it doesn't make a difference which point you call number 1 and you call number 2. All right, I'm just going to call this point number 1. This one over here, point number 2. Now, something to remember about our points, it's always the x coordinate first, comma, y coordinate. And again here, x coordinate, comma, y coordinate. But now, since we have 2 different points, we want to distinguish between what's the x coordinate for point 1 and what's the x coordinate for point 2. And the same with the y coordinate. So that's why we'll label it like this. And since this is my point 1, x1, and then this is y1. For point 2, x2, and this is y2. Okay, and it wouldn't make a difference if you switch these around. If you said, all right, I'm going to do this. This is point 2 and this is point 1. You'd still get the same answer. Okay, so it doesn't matter which one you call point 1 and which one you call point 2. All right, so look, let's use this formula here. M equals y2 over y1. I'll write it out here. M equals y2 minus y1 in the top of the fraction, x2 minus x1 in the bottom of the fraction. Here's our fraction. Okay, let's see. Y2, look, my y2 number is this. Y2 is a 2. And then I'm going to subtract y1. Y1 is, notice here, is -1. So you got to be careful here because we're actually going to end up with minus a negative number. I'm going to write it like this. Okay, why are there 2 negatives here? Well, look, we have 1 negative that's already in the formula. This piece right here is always a negative. And then now we happen to be subtracting a negative number. So that's why here we've got 2 negatives back to back. Okay. Let's go to the denominator here. X2 minus x1. X2 is a 6. So I've got 6 minus, and then my x1 number is a 4. 6 minus 4. Okay, so now I just need to calculate these and see what we get here. Now, look, you could, let's do just the numerator. So just the top piece. So just this here. 2 minus -1. You can do this on a calculator if you want. You could do this on the Desmos calculator. You know, I recommend you do that unless you're 100% solid with adding and subtracting your positive and negatives. You might want to double check your work. 2 minus -1. Subtracting a negative is the same as adding a positive. So this is the same as 2 plus 1, which is a 3. So 3 is our numerator. On the bottom, we've got 6 minus 4. 6 minus 4 is a 2. So this is our answer, 3 over 2. I'll write my final answer down here. M equals 3 over 2. If I were able to simplify that fraction, I would do so. However, 3 over 2 doesn't simplify. You could check it on Desmos. So we'll just leave this here. Final answer. Okay. What I would like you to do now is try these other 2 examples. Try these next 2. So you pause the video, give these a try, and then come back to the video and take a look. All right, hey, I've got the solutions here to these other 2 examples. Let's take a quick look. So for this one here, point number 1, point number 2, I labeled my x1, y1, x2, y2, and then I used the slope formula, y2 minus y1 over x2 minus x1. Okay, again here we're getting minus a negative, so 3 minus -2 is the same as 3 plus 2. It's a 5. Okay, double check your calculations on a calculator always if you're not sure. 4 minus 3 is a 1. So here I have a fraction 5 over 1, which can definitely simplify. Anytime you have a fraction and your denominator is a 1, that simplifies to just a whole number, 5. So here my final answer for my slope, M equals 5. All right, and then here is the third one here. And you know what I did? Just for funsies, I switched up my points. So this point here, I called this point 2, and I labeled it x2, y2. This one here, I called point 1, and I labeled it x1 and y1. Again, it doesn't matter which point you call number 1 and which point you call number 2. The formula will still give you the same answer either way. So maybe you did it the other way, but hopefully you still got the same answer. And here I just wrote down the formula again. We have it up top. I just wanted to write it down again. Then I plugged in my numbers here. y2 minus y1 on the top, x2 minus x1 on the bottom, and 4 minus 12 is a negative 8. 0 minus negative 3 is a positive 3, so this is what we get here, negative 8 over 3. Can we simplify that fraction? You can check it on Desmos, check it on your calculator. That fraction cannot be simplified, so therefore, that's our final answer. All right, if you have any questions with those, please let me know. All right, almost done here. This is our last section. What we're going to do here is write an equation for a line, and we're going to learn a couple different forms. Today we're going to learn the first form, which is slope-intercept form. There's two things that you need here to write an equation in slope-intercept form. You need to know the slope, and you need to know the y-intercept. Okay, now this is what it looks like. Slope-intercept form is like this: y equals mx plus b. Okay, you look at this and you see, wow, it's all letters. There's no numbers. Well, what we're going to do is, this is actually the most general form. This covers all of the different linear equations we can have. Now, to get a specific linear equation, we're going to have a specific slope, and we plug in a number for m, and a specific y-intercept, and we plug in the number for b. And then we leave y and x as our variables. Okay, so what does it say here? We know that m is the slope. Yep, we know that. B represents the y-intercept. Y-intercept. I'm going to abbreviate it INT. Y-intercept. Okay, so it says here, use the given slope and y-intercept to write the equations. You know what? This is actually pretty easy. I'm going to do the first one, then I'll let you try the other two. Let me rewrite like this: y equals mx plus b. And if we want to color code it, let's color code it. Slope is 5, so this means m is equal to 5. Y-intercept here is negative 4, so that means b is equal to negative 4. Okay, so this is what I'm going to do here. B, m, this is my equation, y equals mx plus b. I'm going to go in and replace the m and the b with the numbers that they're equal to. So, m is a 5, b is a negative 4. This is what we get here. Y equals mx. Okay, and here this is plus negative 4, but plus negative 4 is the same thing as minus 4, so we can leave it just like that. This is our answer. This is the equation of the line that has a slope of 5 and has a y-intercept of negative 4. There it is. So look, what I want you to do, copy the same process, repeat the same process, do these last two examples. So pause the video, do those, then you can come back, check the answers, and then we'll be done with this first set of notes here. Okay, this is what I got for these last two examples. Here's the equation in slope-intercept form, y equals mx plus b. There it is for both of those. Take a look. That's it. Hey, we're done with today's notes. So I thank you for your attention, and let me know if you have any questions. All right, catch you on the next one.